Okay, this is the back end of Chapter 8, and what we're looking at are efforts to control air pollution. On the left is an electrostatic precipitator. The electrode imparts a negative charge to particulates in the industrial effluent, and these particles are attracted to a positively charged precipitator wall and then fall off into the collector. And what this does is it removes particulates from the effluent and makes them easier to control and dispose of. On the right are comparisons of emissions from a Delaware Valley steel mill with an electric precipitator turned off on the left and on the right. The toxic dust must be safely disposed of or it does become a pollution problem. But here you see, again, technology being used to solve two problems at once. The problem of industrial effluents along with the problem of maintaining production levels and output so that our standard of living doesn't suffer. Okay, the Clean Air Act, which was passed in 1970, has improved air quality substantially. It was updated and amended in 77 and in 90, and it authorizes the EPA to apply and enforce the Clean Air Act by establishing limits on the amounts of specific air pollutants permitted in the United States. These limits have been placed on lead particulates, carbon monoxide, nitrogen oxide, and ozones. Lead has shown a 98% decrease between 1970 and 1990 as a result, and since '08, the EPA can also regulate carbon dioxide emissions using methodologies such as carbon dioxide scrubbers. Carbon monoxide, sulfur dioxide, and volatile organic hydrocarbons are, along with nitrogen oxide, showed decreases following the passage of the Clean Air Act. Only particulate matter failed to decline. The particulate matter at levels of about 1 times 10 to the 11th parts per billion applies to particles less than or equal to 10 micrometers. Since 1990, the EPA has also monitored particulate matter at a basically at a diameter of about 2.5 micrometers, and these are very small particles. But again, this is again evolving and changing data. But what I want you to notice in this diagram is the difference between the levels of these pollutants between 1970 and 2006. '06 in the green bars and '70 in the dark brown. Okay, so again, substantial drops in virtually all of these air pollutants with the, again, exception of particulate matter. Air pollution is a major issue in developing countries. Environmental quality is a low priority in economic development. Old technology is less expensive and as a result reduces overhead. Air pollution laws are non-existent or unenforced. As a result, air quality is deteriorating rapidly in a lot of developing nations. There's an increasing number of automobiles in these nations as well. There's no pollution control devices for vehicles that are over 10 years old, and we also see a lot of lead pollution from the use of leaded gasoline, which is less expensive to produce than unleaded gasoline. Respiratory disease is a leading cause of death for children worldwide, with more than 80% of deaths in children under 5 who live in cities in developing countries. And here we see a look at an example of this type of air pollution. This is a coal-powered steel mill in China. All forms of pollution are increasing in China as it has become industrialized. Also, we have to account for the fact that productivity is increasing in China as industrialization has advanced and their gross domestic product has increased over the last 2 decades to the point now where China actually exceeds the U.S. in gross domestic product. So we get to our next block of concept checks. What is the U.S. Clean Air Act and how has it reduced air pollution? Well, this act establishes limits on the amount of specific air pollutants permitted everywhere in the United States. Emissions of carbon monoxide, sulfur dioxide, volatile organic compounds, and nitrogen oxides have all decreased since the implementation of the U.S. Clean Air Act. Next question, where is air pollution worse, in highly developed countries or in developing countries, and why? Well, it's worse in developing nations because of the use of outdated technology, and environmental quality is usually a low priority in the race for economic development. Moreover, the number of automobiles is increasing in developing nations, and air pollution laws are rarely enforced. Are there benefits to air pollution? Interesting topic. Global dimming is the gradual reduction in the amount of global direct irradiance at the Earth's surface that was observed for several decades after the start of systematic measurements in the 1950s. The effect varies by location, but worldwide has been estimated to be to be on the order of a 4% reduction over 3 decades from 1960 to 1990. However, after discounting an anomaly caused by the eruption of Mount Pinatubo in 91, a slight reversal in the overall trend has been observed. Global dimming is thought to have been caused by an increase in particulates such as sulfate aerosols in the atmosphere due to human activity. It has interfered with the hydrological cycle by reducing evaporation and may have reduced rainfall in some areas. Global dimming also creates a cooling effect that may have partially masked the effects of greenhouse gases on global warming. Our final block is going to look at indoor air pollution. So we're going to summarize at least 4 sources of indoor air pollution and explain their role in sick building syndrome and describe the effects of indoor air pollution in developing countries. So if we look at developed countries, the most common indoor air pollutants include radon, cigarette smoke, carbon monoxide, nitrogen oxide, formaldehyde, pesticides, cleaning solvents, ozone, asbestos, viruses, bacteria, fungi, dust mites, and pollen. Sick building syndrome manifests as eye irritation, nausea, headaches, respiratory infections, depression, and fatigue caused by indoor pollution. 20 million employees are exposed to health risks from indoor air pollution, and the EPA estimates a $50 billion cost in the loss of work, productivity, and health costs to the economy. The most common air pollutants in developing countries are smoke from indoor cooking with firewood or animal dung, which contains carbon monoxide, particulates, hydrocarbons, formaldehyde, and benzene. Women and children are most exposed and harmed. Lower respiratory infections, eye infections, and lung cancer are the result of this. Basically, if we expose ourselves to these toxicants, they're going to have a detrimental effect on body systems. So this is why we see a problem with these types of practices. The World Health Organization estimates that 1.6 million people die annually from the health hazards of smoke from indoor cooking. Here we see an example. This woman is cooking indoors with open fire or traditional cooking stoves. This results in dangerous levels of indoor air pollution. Let's talk a little bit about radon. It's a colorless, odorless, tasteless radioactive gas. It's an important indoor air pollutant in the United States because it can seep through ground and enter buildings where it concentrates. It causes 12% of lung cancers. Cigarette smoking exacerbates its effects. The EPA estimates that 6% of U.S. homes have too much radon in them, with concentrations seen in southeastern Pennsylvania, northern New Jersey, and New York. Radon is a radioactive substance, hence it is a mutagen. This is why it's considered to be a carcinogen. This is how radon infiltrates a house. Cracks in the basement walls or floors, or openings around pipes and pores in concrete blocks provide ports of entry for radon. Radon, remember, is a gas, radioactive gas. Homes may contain higher levels of air pollutants than outside air, even near polluted industrial sites. So here you're looking at examples of how indoor air pollution can accumulate. We've got suspect areas in the garage, around the dinner table, in the living room, in the bathroom, the dining room, and in the restroom. And we list, again, all the possible sources for indoor air pollution. So we get to our next concept check. What are some common indoor air contaminants? Well, these include radon, cigarette smoke, carbon monoxide, nitrogen oxide, formaldehyde, household pesticides, cleaning solvents, ozone, and asbestos. Next question. Why is indoor air pollution such a serious health hazard in developing countries? Well, it's due to the use of solid fuels for indoor cooking, resulting in increased levels of particulates and carbon monoxide, just to name a couple of the hazardous byproducts. How does radon gas enter buildings? Well, it seeps through the ground and enters buildings through cracks in basement walls or floors, openings around pipes, and pores in concrete blocks. These all provide ports of entry. So here we get a case study in curbing air pollution. This is Chattanooga, Tennessee. It had the worst air pollution in the United States in the 60s. It was so bad that headlights were often necessary during the day. Today the air is relatively clean. The Clean Air Act allowed the city to apply and enforce air quality regulations. In the 2000s, Chattanooga continued to move towards environmental sustainability. They are planning to renovate a brownfield and convert it into an industrial ecosystem where people live near their places of work, as a result cutting down on the production of air pollutants. Okay, that brings us to the end of this chapter. Make sure and review this material as it will be covered on the exam, and I will see everybody in class.